this problem today. So we have to find the number of contiguous subarrays in this array nums. We are given an array and an integer k. We have to find the number of continuous subarrays whose product of all the elements in the subarray is strictly less than k. So we have been given this example, and we have been given k as 100. So we have to find all the contiguous subarrays which has a product less than 100. So we have found this, and we are skipping this one because its product is greater than 100. I have two examples here. One is 10, 5, 2, 6, the same from the question, and the other is this. So let's just brainstorm first. So we have 10, 1 into 10. So we let's keep track of a product. So 1 is to 10, that is 10. So that's less than 100. So I will go ahead and increment a count 1, and then this is 10 into 5, and then you get two arrays. So 5, 10, 5. 10 into 5 is still less than 100. So we get two arrays. So 10 into 5 into 2, that's greater than 100. So we are going to get rid of this 10. So we have 5 into 2. So we get two new arrays. So that is two new arrays. So we have 5 into 2 into 6. And that is also less than 100. That is 60. So we get three new arrays. What did we do? So we calculated in the forward manner, and then we found that 10 is, we can get rid of 10. So we calculated this, and then again we went in the forward manner. So we can have two pointers. So 10, 5, 2, 6. We have one pointer that goes move forward fast, and then another pointer that goes slow. So when so we get all the arrays in between the two pointers. So this went fast, and then this was always here, and then when this exceeds 100, we move this pointer here. So this will be the array now, 5, 2, and then this pointer will move forward, and then this will be the array, and then this pointer will go out, and we are done. So similarly we can solve this one also. We can have the pointer approach. So we have the 10, 5, 90, 100, 101, 2, 6. So I have a pointer here, and I have a pointer here. So the pointer will move like this, and it comes here. So that's greater than 100. So this product is greater than 100. So this pointer will move here, this pointer will move here, and then that's 90. So 90 is still less than 100. So we can take this array, and then we go this pointer will move here, and then this pointer sees that it's greater than 100. So this pointer will come here and sees it still it's greater than 100. So this pointer will move here, you see, and then this pointer will come here, and it finds that this is greater than 100. Then this pointer will move here, and then this pointer comes here. Then they find this is okay, then they edit, and then this pointer comes here, and you have two numbers in the array. You edit, then this pointer comes here, and we are done. So you see, sometimes the slow pointer exceeds the fast pointer. So if I say this is I, and if it is j, sometimes I exceeds j, because so we are going to count the number of contiguous arrays between the pointers like this. So we have 10, 5 and 90. So pointer 1 is here and pointer 1 is here and pointer 2 is here. So the number of contiguous subarrays, if you see this, would be 2. So in the initial one we added 10, then for the second one we added 2, for the third one we added, when there are 3 numbers we added 3. For each product that's less than 100, we count the number of elements within that product to increment the counter. So if you look at multiple examples, you will see this pattern. So where the number of elements within the subarray gives you the count to be incremented. Second pointer was going beyond the first pointer, so it came here and this came here, and then it came here and this came here. So this is greater than 100, so it went ahead. So in this case, if you say j minus I plus 1, you will get 0. So there's nothing to increment. So that's why we make sure that this pointer goes beyond j also. So this will be the increment of count j minus I plus 1, and even if the pointer goes beyond, if the pointer I goes beyond the current j value, then we get 0. So let's code this up. The int, so we will have to have a count that will be equal to 0, and we'll be having a product that will be 1. So for int I equals 0 and j equals 0, I j less than nums dot length j plus plus. And if so, product will be equal to this times nums j, and if product is greater than or equal to k, then product must be divided by I, the previous initial pointer, so I plus plus, and then we can increment the counter first, j minus I plus 1, and then return the count. So there's one edge case here. So if you run this code, this would work for the first example, but it wouldn't work for the second example. Why is that? Because if you look at this k equals 0, so we have to look at the constraints. So this, if you look at this one, if you try this with negative numbers, it won't work. If you try this with the value k equals 0 or k equals 1, it won't work. Why? Because you can look at this constraint. So this numbers is always from 1 to 1000. So k can be from 0 to 10 to the power 6. So if k is less than or equal to 1, what happens? This product is always going to be greater than k. K is, so because product we are setting it to 1, numbers cannot be greater than, numbers is always going to be greater than 1, and if k is less than 1, then this product is going to be always greater than 1. The product is always greater than k. That means this while loop will continue forever and it will go index out of bunch. So how can we fix this one? It's very simple to fix this one. We can fix this by k less than or equal to 1, then return, we can just simply return 0, because there's no value in numbers that's going to be less than k in this case, because number is always greater than or from 1 to 1000. So if it is less than or equal to 1, there's no number, no array in this nums array that's going to be greater than or equal to 1. Less than or equal to 1. So so this should work. Let's try all the examples now. That worked. So we can submit this one and see how it goes. It's successful. So that's about this problem. Thank you for watching. Please subscribe.